the 7-2 notes, and in the 7-1 notes we started talking about multiplying monomials, and there were several different things that we talked about. We talked about what a constant was. We talked about product of powers. We talked about power of a power, and we also talked about powers of a product. And we learned that sometimes we have to add the exponents, sometimes we will multiply them. Same kind of concept goes for dividing monomials, but you're going to see a little bit of a difference. If we're adding when we multiply, we will subtract when we divide. But we're going to see what that looks like in just a second. So we can use the principles for reducing fractions to find quotients of monomials like 10 squared over 10 to the 0 power. And what that means is I can write this out. So let's take a look at this example. If I have 2 to the 7th, that's the same thing as saying 2 times 2 times 2 times 2 times 2 times 2 times 2. I see it 7 times. 1, 2, 3, 4, 5, 6, 7. All over 2 times 2 times 2 times 2, because it's 2 to the 4th. Now, remember that multiplying and dividing are opposites, so I can say, I have 4 of these, and I'm multiplying, so I'm going to get rid of 4 of them in the numerator and in the denominator. And I'm left with 2 times 2 times 2, which is actually just 2 to the 3rd power. So take a look, I have 2 to the 7th and 2 to the 4th. If I subtract 7 minus 4, I get 2 cubed. So let's take a look at this one. If I have t times t times t times t all over t times t times t, I can cross off 3 of them, and I just get t to the 1st power. T to the 4th minus t to the 3rd just gives me t to the 1st. And that actually is called the quotient of powers. So to divide two powers with the same base, remember it has to have the same base, subtract the exponents. Or if I have a to the m divided by a to the p, it's just a to the m minus p. Let's go take a look at some examples. Alright, I have c to the 11th over c to the 8th. That's the same thing as c to the 11th minus 8, which is just c cubed. Okay? Now let's take a look at these other ones. I have more than one thing here though. I have g's and h's. Same thing though, I just worry about the bases. So in g cubed h to the 5th power over gh squared, I'm just going to take g cubed minus 1, because remember this is just g to the 1st power, times h to the 5th minus 2. So I just combine the ones that have the same base. So I get g squared h cubed. Okay, I want you to go ahead and try this next one on your own. Pause the video and then come back when you're ready. So first thing I'm going to deal with is that 4 over 2. Those are just numbers that we can deal with. 4 divided by 2 is just 2. Then I have k to the 7th minus 5, m to the 10th minus 3, and then I have p to the 1st minus 1 because they're both to the 1st power. So I have 2k squared m to the 7th, p to the 0 power. And we haven't learned about that special 0 power yet, but I'm going to tell you now, we'll get to it later in the notes, but I'm going to tell you now, anything to the 0 power is just 1. So I'm just going to say 2 times k squared times m to the 7th times 1. I'm going to combine the 2 and the 1, and I just get 2k squared m to the 7th. I didn't expect you to have that finished, so go ahead and add that into your notes. Next time, if you aren't sure, just anything to the 0 power is just 1. Okay, so we also have something called power of a quotient. And that means to find the power of a quotient, find the power of the numerator and the power of the denominator. So what that's saying is I have a over b, but I'm taking the whole thing to the mth power. You just put that mth power on both the numerator and the denominator. So take a look at example 1. I have 3/5 to the 4th power. That just means 3 to the 4th power over 5 to the 4th power. Let's go ahead and simplify that. So 3 to the 4th power is 81, and 5 to the 4th power is 625. Okay? That can't be simplified anymore because they don't have a least common factor, or a greatest common factor. Okay, so go ahead and do this one. We're going to have r to the 5th over t to the 5th. Okay? Now, I'm not sure what I did here. I must have forgotten to put in that exponent. Let's go ahead and say, Let me look. Let's just put it cubed. So I want you to try this one on your own. And the next one on your own. Pause the video and come back when you're ready. So first thing I have to do is I have to give that piece to each of the exponent, or the numerator and the denominator. So I have 3p cubed, but let's take that whole thing cubed, all over 7 cubed. So 3 cubed, and then p to the 9th, all over 7 cubed. Now 3 cubed is 27, p to the 9th, all over 7 cubed, gives me 343. Okay. The next one, I have 2y squared squared over 3z cubed squared. So I get 4y to the 4th over 9z to the 6th. Remember that when these are on the outside, you just multiply the exponents, and then cannot be simplified. Okay, turn to the next page. This is where we start talking about that zero power. So if you have a power with 0 as an exponent, we will see what happens. So if I have 3 to the 5th minus 5, because I remember I subtract them if they're the same base, I get 3 to the 0 power. Now I'm going to show you why it's just 1. I get 3 times 3 times 3 times 3 times 3, all over 3 times 3 times 3 times 3 times 3. So let's see. If I take this and I can cancel out each of these, but I don't just get 0 because that doesn't give me 0. But if I say 3 divided by 3, I get 1. 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 And 3 divided by 3, I get 1. 1 times 1 times 1 times 1 times 1 is just 1. So just because things cancel out doesn't mean that you get 0 unless you're adding or subtracting. But when we're multiplying and dividing, we get 1. So 3 to the 0 power is just 1. So if I have a to the 6 divided by a to the 6, I get a to the 6 minus 6, which is just a to the 0, which is 1. Okay? So it doesn't matter what you have. If it's inside parentheses and on the outside of parentheses you have 0, you just can say, forget it, it's to the 0 power, it's just 1. So if you have 15 to the 0 power, it's 1. b over c to the 0 power, it's 1. As long as the 0 is for the whole thing. 2 to the 7, or 2 over 7 to the 0 power, it's 1. Now look at this whole big thing. It's in parentheses and there's 0 outside. We don't care what's happening inside, it's just 1. Okay, go ahead and turn to the next page. So this should have had as parentheses and 0. Go ahead and add that in there, and we know that it's just 1. We're going to learn something now that has to do with the division of monomials, and it's probably the trickier part of this lesson, but it's really not that bad. For the negative exponents, we're going to learn that things just flip for us. So it says for any non-zero number, a, and any integer n, a to the negative n is the reciprocal of a to the n. Use the reciprocal of a to the n, or no, also the reciprocal of a to the negative n is a to the n. That's a lot to take in. I'm going to just show you what that means. It's saying if I have 2 to the negative 4th power, I just write it as a reciprocal, which is just flipped. This is the same thing as 2 to the negative 4th over 1. Flip it, and I get 2, or 1 over 2, and then the sign changes for the exponent and it becomes positive 4. So you just flip it upside down, and then you make the exponent positive. Now, 2 to the 4th power is 16. So 2 to the negative 4 equals 1 over 2 to the positive 4, which equals 1 over 16. At the same time, if I have 1 over j to the negative 4th power, it's the same thing as j to the positive 4th power. I put a negative in there, it should not be there, over 1, which is just j to the positive 4th power. Okay? So if it's in the numerator and it's negative, you just move it to the denominator. If it's in the denominator and it's got a negative exponent, you just move it to the numerator, and each time you just make the exponent positive. So let's try an example. Let's make this, oh no, we want to leave that alone, so ignore what I just wrote down. So I have t to the 3rd over t to the 5th power. First thing I would do is I would just go ahead and do that. I would say that's the same thing as t to the 3rd minus 5, which gives me t to the negative 2. That's fine, but I know I shouldn't have a negative exponent, so I'm going to rewrite it as 1 over t to the positive 2. And that would be my final answer. Now let's come down here. I have n to the negative 5th, p to the 4th, over r to the negative 2. I don't have any like bases, so I don't have to worry about combining anything like I did up here. But I am going to move this to the denominator because it's got a negative exponent, and I'm going to move this to the numerator because it has a negative exponent. The p to the 4th can stay where it is because it already has a positive exponent. So this becomes p to the 4th, r to the positive 2, all over n to the positive 5. So I move them to a different part of the fraction, and I make their exponents positive. Okay, let's try the next one. That r to the negative 3rd has to go to the denominator, and the u to the negative 5th has to go to the numerator. And there are some like bases here. But first I'm going to deal with the numbers. I have 5 over negative 20. 5 goes into 20, so it makes it positive 1 over negative 4. Okay, I've dealt with the numbers. I'm going to put tick marks through them because I've dealt with them. Okay, I have r to the negative 3rd and r squared, but I am going to move that to the bottom, so I'm going to write that as r to the positive 3rd times r squared. I'll combine them in the next step, okay? Then I have t to the 4th, and I have t to the 7th in the denominator. I'll combine them in the next step when I have to subtract. And then I have u to the positive 5 now because I'm moving it to the numerator. Okay, so some of these will take more than one step. So I've dealt with the numbers, I've dealt with the r's, I've dealt with the t's, and I've dealt with the u's. So let's go ahead and write down the next step. The 1 over negative 4 stays the same. I'm going to deal with the r's next. I have r to the 5th power. Remember, I add them. Now I have t to the 4th, and I'm going to say minus 7 because I've got to subtract them because one's in the numerator and one's in the denominator. And then I have u to the 5th. So I've dealt with the 1/4, I've dealt with the t's, I've dealt with the r's, and I've dealt with the u's. So now I have 1 over negative 4, t to the negative 3rd, u to the positive 5, r to the 5th. Last thing I have to do, move those t's to the denominator because they have a negative exponent, and I get 1 u to the 5th over negative 4 r to the 5th t to the 3rd. That 3 becomes positive. That's a lot of stuff going on, but it's just like yesterday's lesson where the more you practice it, the easier it will get. Okay, let's go ahead and try out this one. Let's deal with the 2/10 first. I'm going to make that 1 over 5. And then I'm going to say a squared times a to the 3rd. I took that and I moved it to the numerator. I also have b to the 3rd times b to the 1st power. This had a negative exponent, so I moved it to the numerator. Now I'm going to take that c to the 5th to the bottom because it's got a negative exponent, and the c to the 5th to the 4th to the top because it had a negative exponent. So now I rewrite that and I have 1 a to the 5th, b to the 4th, c to the 4th, over 5 c to the 5th. Now up here I took this up to the top and I subtracted, and then I had to move it back to the bottom, and it was just an extra step. Let's go ahead and just say I have c to the 4th over c to the 5th, so I'm going to subtract. I'm going to get c to the negative 1 in the top. But because it's in the top and has a negative exponent, I can just move it to the bottom. Or we could just say the 5 is bigger than the 4. So I know it's going to end up in the denominator anyway. So I'm just going to do normal subtraction. 5 minus 4, get a 1, and it's going to stay in the denominator because it was bigger there. So a to the 5th, b to the 4th, over 5c to the 1st power. If you like to write out all the steps like we did in number 3, by all means, do it. It's not wrong. It's all the steps, but you just don't have to do them in your head. Okay, let's go ahead and try the next one. I have 32 over 4, which is just 8, and it's in the numerator. Okay, I have a to the negative 8, so I can go to the denominator. The reason I'm moving it to the denominator instead of doing like I did up here with the c's is because it's negative and this one's positive, so they're going to get put into the same place anyway, so I'll go ahead and do that first. Then I have b to the 3rd over b to the 5th. The 5 is bigger So I'm going to know it's going to end up in my denominator, and it's just going to be 5 minus 3, which is 2. And then I have 2 of these that are negative, so they're going to switch places. And I want to switch them first and then do the math so that we don't do too many steps in our head and get lost. So I have c to the squared over c to the 4th. So I've dealt with the numbers, I've dealt with the a's, I've dealt with the b's, and I've dealt with the c's. So I have 8 over a to the 11th b squared. Now I have c squared and c to the 4th. The 4 is bigger. It's going to end up in the denominator. So I take 4 minus 2 and I get c squared. Okay? Turn to the next page. We also have to learn about something called order of magnitude. And basically all that is just estimating with exponents and the number 10. So if I'm taking a look, order of magnitude, the definition can be found on page 411. It is used to compare measures and estimates. So estimate and perform rough calculations. So we're also going to say it's the number rounded to the nearest power of 10. Basically what that's saying is you will have 10 as your base and a certain exponent. So if I'm looking at this one, I'm going to round to the nearest 10th. So I know it's 95. I'm going to round up to 100. So I get 100 billion. And if I write it with a base of 10, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 zeros. So I get 10 to the 11th power. And that's all the order of magnitude is you find out what the nearest 10 is, round it, and then you count the zeros and put that above 10. So we're actually not going to worry about this word problem. We'll do it in class together. So that's the end of the notes. Again, remember when you looked at that multiplying monomials and it was kind of confusing, and then we worked a little bit in class and it got better? Same thing with dividing monomials. It just needs to have a little bit of practice, and then it will be easier and it will make more sense and it will be really, really quick, just like multiplying monomials. Go ahead and finish your 7-1 homework. It will be due tomorrow morning. Finish these notes and let me know if you have any questions.